Hello friends, welcome to my channel. In this video we discuss arithmetic progression. So we already know about patterns. We see pattern in nature like in sunflower petals, honeybees, hive and corn. These all consist of pattern. All these form in a particular pattern. In day-to-day life we also see the patterns like rungs of ladder. The length of rungs of ladder decrease uniformly from bottom to top. If the bottom rungs of ladder is 40 cm in length, then it uniformly decreased by 5 from bottom to top. We also see patterns in number. There is a list of number is given. We see there is a pattern. So there is a list of number 1, 2, 3, 4 is known as term. So each number in the list is known as a term. So in the first list of numbers there is a term 1. So when we add 1 in this 1, it is equal to 2, and when we add again 1 to the term 2, it is equal to 3. There is term 3. When we add 1 in 3, it is equal to 4, and when we again add 1 in the term 4, it is equal to 5. So the next term is 5. In this list of number there is a term 100. So when we subtract 20 from 100, we get 80, and again when we subtract 20 from 80, we get next term 60. Again we subtract 20 from 60, we get term 40. Again we subtract 20 from 40, we get next term 20. Now in the next series of number -3, -2. So when we add 1 in -3, we get next term -2. Again we add 1 in -2, we get next term -1. Again we add 1 in -1, we get 0. And again we add 1 in 0, we get next term 1. In the same way we follow the pattern, we find the next term in the next number. So from these list of numbers we observe that the successive term is obtained by adding a fixed number in the preceding term. So in this the term is -3. We add 1 in -3, we obtain the successive term -2. In this -2 is preceding term, we add +1, we get the next successive term is -1. A list of number in which each term is obtained by adding a fixed number to the preceding term except the first term is known as arithmetic progression. So in this, these are two arithmetic progression. So arithmetic progression is a list of number in which each term is obtained by adding a fixed number. That fixed number is called difference. So in these two arithmetic progression, there is 21, 23, 25, 27 and so on 37. And we add 2 in 21, we get 23, add 2 in 23, we get 25, and again add 2 in 25, we get 27 and so on. So each time we add the number is 2. But if we subtract these two numbers, means 23 minus 21 we get 2, 25 minus 23 we get 2, 27 minus 25 we get answer 2. So each time we get the difference of 2. So it is common between the two terms of the arithmetic progression. So this is known as common difference. So in this arithmetic progression there is a number 100, 80, 60, 40 and so on, and in this series the common difference is -20, because 80 minus 100 it is equal to -20. We subtract first term from the second term. Then 60 minus 80 it is equal to -20, 40 minus 60 it is equal to -20. So common difference is -20. So in this arithmetic progression their common difference is 2. And in this arithmetic progression their common difference is -20. So from these two discussions we will learn that the common difference in an arithmetic progression may be positive, may be negative or 0. So we already discussed a series 3, 3, 3 and so on. In this the common difference is 0. So in any arithmetic progression the common difference can be positive, negative or 0. So now we generalize the arithmetic progression. Arithmetic progression is denoted by AP. AP is a arithmetic progression. We also say it is AP series. So in this there is a first term, second term, third term, fourth term, and so on. Again, in this first term, second term, third term, fourth term, and so on, last term is 37. So when we generalize, we write it as A1, A2, A3, A4. So these are A1 first term, A2 second term, A3 third term, A4 fourth term, and so on. AN, it is the nth term. So we find the difference between this series. A2 minus A1, it is equal to A3 minus A2, and so on. It is equal to AN minus AN minus 1 equal to D. D is the difference. In this, AN minus 1 is the term before the last term before the nth term. From any one series of AP, their difference is common. So we already discussed these two series. In this series, their difference is equal to 2, and in this series, their difference is equal to minus 20. So difference is the common. Let me take one more example. There is a AP series 1, 3, 5, 7, 9, and so on. In this first term, A, it is equal to 1, and difference D, it is equal to 3 minus 1, 2, 5 minus 3, 2, 7 minus 5, 2. So difference is a 2. It is a common. So first term is A, it is 1. Common difference is D, it is equal to 2. So 1 plus 2, we write it as A plus D equal to 1 plus 2, it is equal to 3. This is the second term. Now in third term, first term A, it is equal to 1 plus 2 into difference is 2, and it is equal to 5. So it is the third term. We write it as A plus 2D. So A plus 2D. A is first term, D is difference, and it is equal to third term. Third term is 5. Now in fourth term, it is equal to 1 plus 3 into 2. It is equal to 7. And in generalized, we write it as A plus 3D. This is the fourth term. A plus 3D, it is equal to fourth term. Now fifth term, 1 plus 4 multiply 2, it is equal to 9. So we write it as A plus 4D. 4 and 2 is difference to D. So A plus 4D equal to 9. This is the fifth term. So in general, AP series is write as A plus D, A plus 2D, A plus 3D, and so on. This is the generalize of AP series. In this, A is equal to first term and D is equal to difference. That is the common difference. Arithmetic progression, that means AP series is of two type, in which last term is given and in which there is no last term. The AP series in which last term is given, that is known as finite series, and AP series there is no last term is given, that is infinite series. In this last term is given, that is 37, so it is finite series, and in this no last term is given, it is a infinite series. So next topic is form AP series. In this first term, A is equal to 6 and difference D is equal to 3. These two things are given, we form a series. So we know generalization of AP series. A plus D, A plus 2D, A plus 3D, and so on. So in this A is equal to first term, it is given 6 and common difference D is given. A plus D, D is equal to 3. A plus D, it is equal to, A is first term, it is 6 plus D, D is equal to 3, and 6 plus 3 equal to 9. Next term is A plus 2D. It is equal to A. A is equal to 6 plus 2 into D. D is 3. And 6 plus 6, it is equal to 12. So next term is A plus 3D. A is equal to 6 plus 3 into D. D is the difference. It is also given 3 and it is equal to 15. So the AP series equal to A. A is first term. It is 6. A plus D. It is equal to 9. A plus 2D. It is equal to 12. And A plus 3D. It is equal to 15. And so on. This is the AP series. So when first term and the common difference is given, we find the AP series. So now check the given series is AP or not. There are two series given. We check these are AP series or not. So in the first, there is a minus 7. A is equal to minus 7. A is the first term, then minus 9. So we find their difference, common difference. It is A2 minus A1, minus 7 is A1, minus 9 is A2, minus 11 is A3, minus 13 is A4, and so on. So A2 minus A1, A2 is minus 9, there is minus sign, and A1 is minus 7. So minus 9 minus minus overtake, it is plus 7, minus 9 plus 7, it is equal to minus 2. So now we find the difference in next term A3 minus A2. So difference between A3 and A2. A3 is minus 11, minus sign, then A2 is minus 9. This minus sign and A2 minus 9. It is equal to minus 11, minus minus overtake, it is plus 9. So minus 11 plus 9, it is equal to minus 2. So difference between A2 minus A1 equal to A3 minus A2. It is equal to minus 2. So difference is equal. So when the difference is equal, the given series is a AP series because their common difference equal to minus 2. So in the next series, there is 1, 1, 2, 3, 5. We check the given series is a AP or not. So we mark it as A1, A2, A3, A4, A5. So we subtract the term A2 minus A1, 1 minus 1, it is equal to 0. And A3 minus A2, A3 is 2, A3 minus A2, it is equal to 2 minus 1, equal to 1. So A4 minus A3, 3 minus 2, it is equal to 1. So the difference between two terms A2 minus A1 is not equal to A3 minus A2. So when the difference is not equal, the given series is not AP series because their difference is not equal. So this series is not a AP series. The given series not AP series. So in this given series, their difference is equal. So in first series, their difference is equal, common difference is equal to minus 2. So it is a AP. So any series is AP if their difference is equal. If their difference is not equal, then it is not a AP series. Now we move to our next topic, nth term of an AP. So in this question, we learn how we find the nth term of the AP series. So we know the generalization of AP series A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. We find the number of terms. In this, we given series is 1, 2, 3, 4, 5, and so on. So it is easy to find because when we add 1 in the 1, we get next number. Again we add 1 plus 2, then we get next number. We adding the 1 in this, we get the next number. So when we add 1 in 5, we get next number 6, and so on. But if we need to find the 100th term, right, we have to find 100th term, then we continuously doing by adding 1 and 1 again, or we using this series. So it is very long procedure. So we have to find nth term of the AP series, means 58th term we need to find. Any term in the AP series that we have to find. We will learn how we find nth term of the series. So there is the generalization of the AP series, but there we suppose A1, A2, A3, A4 up to so on. We find the nth term of this series. So there we suppose a1 is the first term, it is equal to a1 is first term, it is equal to a, and common difference it is equal to d is the common difference. So in this a1 equal to a, it is the first term. Now we write a2 equal to a plus d. A plus d is second term. So a plus d. A2 is the second term. There is a d. This is the second term. We write here 2 minus 1d. 2 minus 1d, it is equal to d. So a3 equal to a plus 2d. It is equal to a plus, there is third term, 3 minus 1d. 3 minus 1 equal to 2d. And a4 equal to a plus 3d equal to a plus fourth term. We write 4 minus 1d. So now we generalize an. An equal to, there is first term a plus 4 minus 1, 3 minus 1, 2 minus 1. So 4 minus 1, it is a fourth term. 3 minus 1, it is a third term. 2 minus 1, it is a second term. Then we find nth term, it is n minus 1 into d. So the generalization of AP series an equal to a plus n minus 1d. In this a equal to first term, n equal to number of term, and d is equal to difference. D is equal to common difference. So by using the generalization of an AP series an equal to a plus n minus 1d, we can find the any number of terms. So in this n is the number of terms we can find easily. So let me take an example. There is a series 2, 7, 12 and so on. We find its 10th term. So in this first term is given, it is equal to 2, and difference is given 7 minus 2, it is equal to 5. And we find n 10th term, it is n is equal to 10. So a10 equal to a is the first term, it is a 2 plus n minus 1 plus n equal to 10 minus 1 d is equal to 5. So it is equal to 2 plus 10 minus 1 9 into 5, it is equal to 2 plus 9 multiplied by 5, it is equal to 45. So 2 plus 45, it is equal to 47. So 10th term of this series is equal to 47. So by using this generalization an is equal to a plus n minus 1d, we can easily find any number of terms. So now we move to our next topic, sum of first n terms of an AP. We learn how we find the sum of AP series. There is one series given 1, 2, 3, so on, last term is 5. So in this last term is given, it is a finite series. So 1, we add 1 in 1, it is equal to 2, 2 plus 1, it is equal to 3, 3 plus 1, it is equal to 4. So now we add this series. When we add this series, 1 plus 2 plus 3 plus 4 plus 5, it is equal to 15. Let me take one more example. There is a series 1, 2, 3, so on up to last term is 100. So we have to find the sum of 100 terms. So it is very difficult to add one by one. So we use the formula to find the sum of 100 terms. S is equal to n over 2, 2a plus n minus 1d. So in this n is the number of term, n over 2, 2a. We also write it as a plus n minus 1d. So we already discussed a plus n minus 1d. A plus n minus 1 d, it is equal to an. An is the last term. So n over 2 a plus an. So s equal to sum of number of terms equal to n over 2 a plus an. So by using this formula we find the sum of 100 terms. In this, n is equal to 100, a is equal to first term, it is 1, and an is last term, it is equal to 100. So by using the formula n over 2, n is 100 over 2, a first term, it is 1, an is last term, it is 100. So 100 divided by 2, it is equal to 50. 1 plus 100, it is equal to 101. And 50 multiplied by 101 equal to 5050. So the sum of first 100 terms equal to 5050. By using these formulas, we solve the exercise. So this is all about the arithmetic progressions. If you have any query, then you can comment on this video, like this video, subscribe my YouTube channel.